Right. Okay, yes, we are recording. Well, good evening, or whatever the time you're watching this. It's evening right now when I'm recording this. I hope you are all doing okay. We are doing actually more than okay by God's grace. Let's have a prayer and start our session. Father God, I thank you for another opportunity to study the science of mathematics and learn about, just in small fraction, learn about your great wisdom and the way that you have created this world, because we can see the mathematical pattern in the creation of this world. Help all of us to think mathematically and to see your glory, your beauty in science of mathematics, and also in creation, which is a reflection of your majesty. I ask your blessing upon all these dear students, both online and on campus, and may we learn and be studious in this course and all the other classes that we are taking. And we do this not only to pass a class, but also to learn and become better equipped to serve you, serve your church. Commit this session into your hand. We pray all these things in Jesus' mighty name. Amen. If you go to your Populi, on the Populi, if you go and look at lesson number 3, there is an old recording of this session under lesson number 3. I have kept that because in that lesson I answered some of the questions from the previous assignment regarding the set theories. So you may want to look at that to answer some of your questions. But I'm recording this new lesson, this new session for session number 3, so that everything to be refreshed. All right, we are going to look at numbers and number theory. And let me go to share screen. Okay. All right. And let's. Okay. In this session, we are going to look at number theory and the real number system. We are dealing with numbers at their application, all kind of stuff from approximation to arithmetic to complex numbers, irrational, real numbers, and everything else. Number theory. What is number theory? Number theory is the study of numbers and their properties. They are the alphabet of the language of mathematics. Numbers we use to count are called the counting number or the natural numbers. So natural numbers are the numbers that we use to count. Because we usually begin counting with number 1, the set of natural numbers begins with 1 and is denoted by n for natural number. Then you have those braces, and then 1, 2, 3, 4, 5. Any natural number can be expressed as a product of 2 or more natural number known as factors. So 4 is a natural number, is a product of 2 times 2. 2 times those 2 2's are factors of 4's. 8 is a product of 2 times 4. These 2 and 4 are factors. 16 is a product of 4 times 4. 19 is product of 19 times 1. These 2 numbers are the factors for this natural number. The numbers 1, 2, 3, 6, 9, and 18 are all factors of 18, because you can get 18 by multiplying, like 6 times, for example, 2 times 9 is 18, 6 times 3 is 18, and each of these numbers divide 18 without a remainder. Okay. divisibility, if A and B are natural numbers, we say that A is a divisor of B, or A is divisible by B, or A divides B, symbolized by D. A divides B. If the quotient of B divided by A has a remainder of 0. So let me explain what we mean. If A divides B, then B is divisible by A. For example, 4 divides by this bar 12. Because when you divide 12 by 4, the quotient of 12 divided by 4 has a remainder of 0. 12 by 4 is 3, and then when you do the multiplication and subtraction, the remainder is 0. Note, every factor of natural number is also a divisor of that natural number, okay? So if we have, for example, 6 times 3, we get 18. So these 6 and 3 are also divisor of 18. Do not confuse the symbol A bar B and A, B, or A divided by B. Don't confuse this. A bar B means A divides B. But this way, A slanted B, a slanted bar B means A divided by B. Don't confuse these two together. All right? Let's talk about prime and composite numbers. Every natural number greater than 1 can be classified as either a prime number or a composite number. No. A prime number is a natural number greater than 1 that has exactly 2 factors or divisor, itself and 1. A composite number is a natural number that is divisible by a number other than itself and 1. Number 1 is neither prime or composite because it's called unit. Okay, so let's say look at this table. We want to find all the prime numbers less than 100. What do we mean by prime number? The numbers that can be divided only by itself and 1 and have no remainder, okay? So let's, in order to do that, we cross out 1 because 1 is not a prime number. Circle 2, that's the first prime number. Then cross out all the multiples of 2. So 1 is not, then 2 is, because 2 is divisible, is either by itself and 1. Then all its multiples, 4, 6, 8, 10, and so on, we cross them also. Circle the next prime number, 3, and cross out all its multiples. Then circle the next natural number, 5, and cross out its multiple. The next one is 7, cross out the multiples. The next one is 11, cross out the multiple. So then you have you have completed the chart. See, here it is. We cross out 1 because that's a unit. It's not neither prime or composite. Then we circle 2. Then we multiply, we cross out all the products of 2. Because, for example, 4 is divisible by itself, it's divisible by 1, and it's divisible by 2. So it cannot be a prime number. Or 6, the same. 8, the same. 10, the same. Then we come to 3. This is the next prime number. We circle it, and then we cross out its multiple. 6 or 9. 9 can be divided by itself, can be divided by 1, and it can be divided by 3. Therefore, it cannot be prime. Then we go forward. 11. Circle 11, but then cross out its multiple, like 22. Then you go on to 13, and you keep doing this to the end. You have the prime numbers from 1 to 100. These are the prime numbers, the one that we circle. So we cross out 1, then we circle 2, We eliminate all its product because the products of two cannot be prime. They are composite because they can be divided by itself, by 1, and by 2. We do this for 3, 4, 5, 7, 11, 13, 17, and so on. And here we get all the prime numbers, the ones that are circled between 1 and 100. The fundamentals theorem of arithmetics. Every composite number can be expressed as a unique product of prime numbers. Like we looked at it, like 6 is a product of the 3 times 2. Using a factor tree to find out the prime factorization of a composite number. That's, we use factor tree. To find the prime factorization of a number, select any 2 number whose product is a number to be factored. If the factors are not prime numbers, continue factoring each composite number until all the factors are prime. Now, let's look at here. You have number 210. 210, you're using prime factorization by branching. 2 branching is a product of 2 times 105. Now, 105 can also be factored. It's 3 times 35. 35, that can be factored. It's a product of 5 times 7. Or 210 is a product of 14 times 15. 15 times 15. 15 is 3 and 5. 14 is 2 times 7. Okay? We get the same final result at the end. You have 2, 3, you have 2, 3, 5, and 7. These are the prime numbers. You cannot go any further. All right? Now, if you want to find prime factorization by division, you have this big number, okay? 34,200. Divided by 2, we get this, 17,100. Divided by 2, we get this. Divided by 3, we use divisibility test for 3, and we get this one. And again, divided by 3, we get that number. Divided by 5, we get that. Divided by 5, we get 90. This is a prime number, so we stop right here. The greatest common divisor, GCD, of a set of natural number is the largest natural number that divides without any remainder every number in that set. For example, what is a GCD of 12 and 18? Divisor of 12 are 1, 2, 12 divided by 2 is 6, no remainder, 3, 12 divided by 3 is 4, no remainder, 4, 6, and 12 itself. 18 is 1, 2, 3, 6, 9, 18. Now, the common divisor are shown in bold. These are the common divisor. 1, 2, 3, 1, 2, 3, 6, 6. The common divisor, 1, 2, 3, 6. So the greatest common divisor, the GCD, is 6. Okay? Okay, determining the GCD of 2 or more number. Determine the prime factorization for each number. List each prime factor with the smallest exponent that appears in each of the prime factorization. Determine the product of factors found in step 2. Let's look at example 3 and 4, page 232 and page 233 of your textbook. Just one moment. If you look at your textbook, page 232. Okay, we are looking at example number 3 and example number 4. Let me see if also I can do something else. Maybe that can help. Let me check. Let me see if I can do this one here to help you. It says, example number 3. We have write the prime factorization for each number. Begin by writing the prime factorization of 216 and 234. So let me see. We have 216. Oops. 216. Okay. Just ignore this one. Okay. All right. So we make 2 branches. We have 216 is a product of 2 and 108. Okay. Let me make this a little bit bigger. Then 108. Oh, come on. Oh, sorry. Okay, sorry. Let me go to here. Okay. All right. 108 is a product of 2 times 54. Oops. 2 times 54. Now look at 54. 54 is a product of 2 times 7, 2 times 27. 27 is a product of 3 times 9. 9 can be branched out, is a product of 3 times 3. Now look here. Again, let me erase this thing here. So we have 2, 1, 2, 3. So I have 2 to power of 3 times here 3 and 3 times 3 to power of 2 is equal to 216. Okay? This is writing the prime factorization using the branch method. Now, if you want to do 234, let's look at 234. Okay, you branch it, you get 2 times 117. 117 can be branched out to 3 times 39. Okay, oh, sorry about 9. 9, not very nice. And then 39 can be branched out to 3 times 13. Okay, so oh, I'm sorry. We have here, I forgot. This is 1, 2, 3, 3, 1, 2, and this one. So this should be actually 3 to power of 3, not to power of 2. Here we have 1, so we have 2 to power of 1 times, then we have 1 and 2, 3 times 3 to power of 2 times 13. 13 to power of 1 equal to, this will be equal to 216. 34. All right? So these are the, using the prime factorization. Now, it says we want to find the GCD, the greatest common divisor. All right, so let's go here. So if we have, let me write it again, 216 is equal to 2 to the power of 3 times 3 to the power of 3. Okay, and 234 is equal to 2 to the power of 1 times 3 to the power of 2 times 13 to the power of 1. Okay, so then 2 is a prime number common to both factorization. Got 2 in both of them. 3 is a common in both of them. 13 is not. So the greatest common divisor is a prime number to both factorization, would be the greatest common divisor would be 2 to the power of 1 times 3 to the power of 2. You pick the one with the least exponent here. 2 to the power of 1 and 3 to the power of 2. So the GCD is this. Greatest common divisor is 2 to the power of 1 times 3 to the power of 2. Okay? Or it is equal to 18. This is the greatest common divisor of 216 and 234. So what do? You start with branching, you do the prime factorization, you write it down, then you find the common factors in each, 2 and 3. You pick the one with the least exponent, 1 and 2, and that's your GCD. This is the answer you were looking for. Okay? We can also look at example number 3. Let me get a new one. Okay. Let's look at example number 4 on page 234. Okay. Again, we have two numbers for an intermal league. You need to divide 40 men and 24 women into all male and all female teams so that each team has the same number of people. What is the largest number of people that can be placed on a team? Again, because 40 men are to be divided into teams, the number of men on each team must be a divisor of 40. Because 24 women are to be divided into teams, the number of women placed on a team must be divisor of 24. So we want to find we have to do the factorization of 40 and 24. Then we find the greatest common divisor. So again, you have 40 men and you have 24 women. Again, because 40 men are to be divided into teams, the number of men on each team must be a divisor of 40. All right? So I do the prime factorization. 40 is 10 times 4. 10 is a multiple of 5 and 2. Now we stop because these are both prime. And 4 is multiple of 2 and 2. And we stop because these are prime. So 40 is equal to 5 to the power of 1 times 2 to the power of 3. Now, because we have 24 women, then they are to be divided into teams. The number of women placed on a team must be a divisor of 24. So we do prime factorization tree. 24 is a multiple of 2 times 12. Did we stop here because this is prime? 12 is a multiple of 4 times 3. You stop here because this is prime. But 4 is a multiple of 2 times 2. Okay, so these are the numbers that we have. 2, 2, 2, and this one. These are prime. So 24 is equal to 2 to the power of 1, 2, and 3 times 3 to the power of 1. Then again, you find what's common between both of them. Well, the common between both of them is 2. Oops. Okay, so this is here, and this here. These are common between both of them. So the GCD is equal to 2 to the power of 1, actually. The greatest common divisor is 2 to the power of 3, because that's a least common denominator that we least exponent that we have, or 8. So the largest number of people that can be placed on a team is 8. Thus, the 40 men can form 5 teams with 8 men per team, and 24 women can form 3 teams with 8 women per team. Okay? All right, I hope this is clear. Let's continue. All right, let's go again. Stop share, and let's go to our PowerPoint. All right, we did that. Okay, so you see we determine the prime factorization of each number, list each prime factor with the smallest exponent, and then determine the product of the factor found in step 2. That's what we did. List common multiples. LCM, least common multiple of a set of natural number, is the smallest natural number that is divisible without a remainder by each element of that set. So, for example, what is the LCM, least common multiple of 12 and 18? So, multiple of 12, so you find the multiple of 12, 12, 24, 36, goes on, 144, keeps on going. Remember these 3 ellipses. And multiples of 18, 18 times 2 times 3 times 4, and keeps going. Some common multiples of 12 and 18 are these, the one that I've written them for you in bolds. The least common multiple is 36, the smallest number that is divisible by both 12 and 18. You can divide 36 by 12, divide 36 by 18. 36 divided by 12 is 3, 36 divided by 18 is 2, remainder is 0. Finding the least common multiple of 2 or more numbers. Again, we do the prime factorization, list each prime factor with, this time, with the greatest exponent that appears in any prime factorization, and then find the product of that factor in step 2. Let's look at example 5 and 6, page 234 and 235 of your book, textbook. Okay, example 5, finding the LCM. Find the LCM of 144 and 300. You write the factorization of each number, write the prime factorization of 144 and 30 and 300 would be, if you go and do the 3, would be 2 to the power of 4 times 3 to the power of 2, 300 2 to the power of 2 times 3 to the power of 1, 5 to the power of 2, and then you find the common factors with the greatest exponent. Okay, thus we have. Let me show it to you. Maybe again that can help if I show it to you. Let's go to here. Yeah, let me get a new in this. Come on. All right. Again, we want to find LCM. Okay. So LCM, the least common multiples of 114 and 300. So if you do the 3 factorization, I'm not going to do it here. 144 will end up to be equal to 2 to the power of 4 times 3 to the power of 2. Okay, and 300 will be when you do the prime factorization 3, it would be 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 2. Okay, now to find LCM, the least common multiple, you find the factors that are common. We have here 2 and 3. So it's 2 times 3. And then with the one with the greatest exponent, we pick 4 and we pick 2. So this is, we select the common factor raised to the greatest power to which is occur in this factorization. Actually, as I said, you select every prime factor. So it's 2, 3, and also 5. So 5 is only the power of 2. It's the least common factor, least common multiple. So you select all the factors. So this would be your answer. Okay. All right, let's look at example number 6, solving a problem using the LCM multiple on page 235. A movie theater runs its films continuously. One movie runs for 80 minutes. The second runs for 120 minutes. Both movies begin at 4 p.m. When will the movies begin again at the same time? Okay, the shorter movie lasts 80 minutes. Okay, the shorter movie lasts 80 minutes. It begins at 4, so it starts at 4 o'clock, so it goes all the way, and it will end at 5:20. The other one, it takes 120 minutes, so if it starts, it takes 120 minutes, so if it starts at 4, it will go till 6 p.m. All right. You're asked to find when the movies will begin again at the same time. Therefore, we are looking for the least common multiple of 80 and 20. We want to find the least common multiple and then add this number of minutes to 4 o'clock p.m. So again, when you do the factorization, you end up 80 is, you do the prime factorization is product of prime number 2 to the power of 4 times 5 to the power of 1, and 120 is a product of 2 to the power of 3 times 3 to the power of 1 times 5 to the power of 1. Oh, I'm sorry. Let me do this. Five to the power of 1. Okay. Now we select the prime factor with the greater exponent from each factorization. All the prime factors. So we have, these are all 2, 3, and 5. So LCM would be 2 times 3, because we have 3 here, times 5. And we pick the one with the greatest exponent. So we pick 4 for 2. We pick, well, I mean, 3 is only 1, so 1, and 5 is 1. So this is the LCM. 2 to the power of 4, 3 to the power of 1, and 5 to the power of 1, which is 240. 240 minutes. Now you add that to 4 p.m., 240 minutes, you end up, you will come, 240 minutes is 4 hours, so you end up, it will take you to 8 p.m. So at 8 p.m., these two movies will start at the same time. Okay, you see how these prime factorization, LCM, can be used in real life. All right, let me continue. Okay, let's go back again here, and let's go back to our PowerPoint. Okay, we did that. 234 times 5. Integers. Integers are, if you have the number line, here 0, the origin, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, and so on. These are all integers. These are called positive integers. These are called negative integers. We can, if you have positive, 2 positive added together is positive. If we have 2 negatives added together, the answer is negative. Minus 3 plus minus 4 is minus 7. If you have 2 numbers, the positive is greater than the negative, like let's say you have positive 4 plus minus 3, the answer is positive 1. If the negative is greater, the answer is negative. Subtraction, just add the opposite. Change the subtraction sign to an addition sign, change the sign of the second number, now follow the number here. Multiplication, plus times plus is plus, minus times plus, minus times minus is plus. When they are same, the answer is always plus. When they are different, either in multiplication and division, the answer is negative. All right? This is the integers. This is the origin, negative, positive. Plus 4 and minus 4, they are opposite of each other. There is 8 units distance between them. 4 here and 4 over here. Okay? The set consisting of a natural number 0 and a negative of natural number is called a set of integers. The number line is a graph. This is a number line to visualize the set of integers as well as the sets of other numbers. This symbol, we use them to show greater and smaller. For example, it says using the numbers line as a reference, insert either this sign or that sign. Now, when you have this one, it means when the number is here and the other one is here, we say this number is less than the other one. if the number is here, means this number is greater than the other one. For example, -4 and 3, which is +3. -4 is here. +3 is here. Which one is bigger? This one. This one is bigger. So, I don't know, let me see if I put that, no. Let me again, we have -4 + 3, -1, -5, -5, -2, 0, and -3. Let me go to my tablet to maybe show that for you. That would be easier. Okay, let me again clean this. Okay, we had, for example, these were the numbers that we had. If you have, oops, that's right. We have -4 and 3. When I don't put any number, this means it's positive. Okay, so which one is bigger? +3 is bigger than 4. So if this goes, the bigger number goes inside this mount. If we have -1 and -5, you know, if you have the number line, for example, here, oh, I'm sorry. So, difficult to draw on this pad. If here is the 0, and here would be 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. -5 would be here. -1 would be here. This is bigger than that one. So -1 is bigger than -5. So sign will go this way. We have -5 and -2. Let me do this number line better. Okay, this is 0. There's 1, 2, 3, 4, and 5, sorry. And 1, 2, 3, 4, and 5. Here is -5. Here is -2. Which one is bigger? -2. So the sign goes that way. If we have 0 and -3, which one is bigger? 0 is here, -3 is here. Which one is bigger? 0. 0 is bigger than -3. Okay? I hope this is clear. Absolute value. The absolute value of an integer is denoted by a inside 2 bars. Is a distance from 0 to a. So it's always positive. It can never be negative. for example, the absolute value of -3 is 3. So remember this. Please remember that. If you are talking about absolute value, if I put -3 here, its absolute value is 3 positive, because you're looking at the distance from that number to 0. Okay? Rules for addition of integers. If the integers have the same sign, again, add their absolute value. The number that is bigger, if the positive is bigger, it becomes positive. If the negative is bigger, it becomes negative. If they have the same sign, you just add them together and put a sign. If the integers have different signs, if you want to add them, the number with the greater absolute value, the sign of that number, that integer, will become the sign for the final addition of the two numbers. Okay. Now let me again maybe show it here on my pad. If I have, for example, if I'm adding two numbers, 4 plus 3, but if they are both, they have the same sign, positive, well, the answer would be +7. If they are both negative, -3 plus -3, okay, add their absolute value, 3 and 3 is 6, and then put the sign, because they have the same sign. If they have different values, different signs, for example, if you're adding -4 plus +3, then you look at the one with the greater, so you add plus, you have +3 -4. So the answer would be, you're actually subtracting, you're adding 3 to -4. If this is a number line, here is -4, okay? If I'm adding 3 to it, I'm going 3 units this way. 1, 2, 3. And I end up here, which is -1. So -4 plus 3 is -1. Okay? But for multiplication, if the numbers are if the signs are the same, +4 times +3, just multiply them, and the answer is it's always plus. If you're multiplying two numbers that are negative, when the signs are the same, multiply them again. Negative times negative is plus. But if the signs are different, one is negative, multiplied by one is +3, you end up having plus times negative is negative. 3 times 4, 12. Same with division. If I'm dividing, let's say, -4 divided by -2, the answer is +2. But if I'm dividing -4 divided by +2, then the answer would be, the signs are different, would be -2. Okay? Let's go back. Again, like -3 plus -2. You have -3 here, 3 units, 3 distance unit to the left of 0, and 2 more units, you end up -5. Okay? Subtraction using number line. Here's a number line. You got -1 plus -8. Here's number -1. -8, if I'm adding -8 to -1, it means I am going 8 units to the left of -1. So I got 1, 2, 3, 4, 5, 6, 7, 8. I end up to -9. So you see, I add them together, they have the same sign, and put the sign together. -9. Multiplication, as I said, if they're the same, always positive. One is different, always negative. Evaluating exponential expression. Because exponent indicate repeated multiplication, rules for multiplying real numbers can be used to evaluate exponential expression. Let's look at example and checkpoint 6 on page 244. Go to page 244, example number 6. Let's do some of that here also. And let's get a clean slate. Okay. We have example number 6, example 6a. We have in a parenthesis -6 to power of 2. Okay. So -6 to power of 2, here is your base. 6 is your base. This is your exponent. This is your sign. This means -6 to power of 2 is -6 times -6. 6 times 6, 36. The rule was if they are same sign, it will be positive. All right? Let's look at, if we didn't have a parenthesis, -6 to power of 2. What would be the answer there? Here, you got to be careful. This 2 is only for the base. This 2 is for the whole thing, base and the sign. Here, it only goes for the 6. Okay? So this means, like, you put the negative here, 6 times 6, close the parenthesis, negative here, 6 times 6 is 36, so you end up with -36. You got to be careful. Where does this exponent extend? For the whole thing or just for the base? Let's look at number D. We have -2, okay? Then the parenthesis to power of 4. That means the 4 applies both to the sign and the base. It means you got -2 times -2 times -2 times -2. Minus times minus is positive. Times negative, negative. Negative times negative is positive. 2 times 2, 4 times 2, 8 times 2, 16. Okay? I hope this is clear. Let's go back to our PowerPoint. Dividing the integers, same as multiplication. If they have the same signs, let me make this. If, oh, come on. If they have the same signs, it's positive. Negative divided by negative, positive. If they are mixed signs, it's negative. Plus divided by negative is negative. Negative divided by positive is negative. Okay. Same sign, positive. Different sign, negative. Order of operation is very important. First, perform all the operation within the grouping symbol, within the parentheses. Evaluate all the exponential expression. Do all the multiplication and division in order in which they occur, working from left to the right. Finally, do the addition and subtraction in order that in which they occur, working from left to the right. In other words, the order of operation are parentheses, exponent, multiply, divide, add, and subtract. PEMDAS. Let's look at example on checkpoint 7 and 8, pages 246 and 247. Let's go to those pages, 246 and 247. Oh, okay. Yeah. And wait. Let me again go to my graph. And get a new fresh page. Here. On page 246, example number 7, we have here we have 6 to the power of 2 minus 24 to the power of 1 divided by 2 to the power of 2 times 3 plus 1. Okay. First of all, there are no grouping symbols, thus we begin by evaluating exponential expression. Then we multiply or divide, and finally we add or subtract. So we have 6 to the power of 2 minus 24 divided by 2 to the power of 2 times 3 plus 1. Okay, first we do the exponential. 6 to the power of 2 is 36. Okay, minus 24 divided by 2 to the power of 4, 2 to the power of 2 is 4, multiply by 3 plus 1. Okay, then we do okay, one moment. We have 36 minus, we have 36 minus 24 divided by 4 times 3 plus 1. So when we do this, okay, I can write this also as 36 minus 24 divided by, you have 36 times, actually this becomes 3 times 4, 12 plus 1. So 36 minus 24 is 12. Okay, all right. I'm sorry, I got an email from one of the students. Distracted me. One moment. Let me see. What is this student is asking? No. Okay, I find what's the problem. Never mind. We have, I'm sorry, it just distracted me. Let me start over again. In the middle of, we got an email from one of the students. All right. So we perform the multiplication and division from left to right. We start with 24 divided by 4. Okay, you see here, we have 24 divided by 4. 24 divided by 4 is what? 6. Okay? So we have 36 minus 6 times 3 plus 1. Okay? Then now we do the multiplication. 6 times 3. 36 minus 6 times 3 is 18. Plus 1. 36 minus 18 is 18. Okay? 36 minus. Plus 1 is 19. So this is the answer. Okay. Let's do example number 6 on page 247. We have parentheses minus 6 to power of 2. Then we have 5 minus 7 to power of 2. Then we have parentheses minus 3. Okay. Again, because we have grouping symbol, we perform the operation within the parentheses. First, we have minus 6 to power of 2, 5 minus 7 to power of 2, times minus 3. So this is equal to minus 6 to power of 2. First, let's do inside here. Minus 5 minus 7, this is minus 7 is bigger, so it becomes minus 2 to power of 2 times minus 3. All right. Then we do the exponents. Minus 6 to power of 2 is minus 6 times minus 6 is 36 plus. Minus. Here is a parenthesis. Minus 2, you see this 2 applies to sign and the base, would be plus 4. Minus times minus, positive 2 times 2 plus 2 times 2 is 4. So we have 36 plus 4. Then times minus 3. Okay? All right. Now, here we have 36. This minus gets multiplied by this, becomes negative minus 4 times minus 3. Again, 36, you have minus times minus plus 4 times 4, 12. So the answer is 48. Okay. I hope this is clear. Let's go back to our PowerPoint. In order of operation. Parentheses, exponent, multiply, divide, then add and subtract. Order of operation, you can remember the order of operation by this. Please excuse my dear Aunt Sally. Please, parentheses, excuse, exponent, my dear, multiplication and division, Aunt Sally, addition and subtraction. Rational numbers. Oops. The set of rational numbers denoted by Q is a set of all numbers of the form P is divided by Q, where P and Q are integers and Q is not 0. Every rational number, when expressed as a decimal number, will be either a terminating or repeating decimal number. What do we mean? Let's look at this. I think this graph helps. Fundamentals, laws of fraction regarding rational number. If we have A divided by B and a number C is not equal to 0, So if we multiply both A and B by C, A over B is equal to A over C, and over A times C times B over C. 1 over 2, if you multiply both by 2 over 2, you get 2 over 4, is the same. This is 1 part divided by the whole. If you multiply by 2 over 2, it means that you're dividing it by 4 parts. You're picking 2 out of 4 parts. 2 out of 4 parts is the same as 1 out of a half. Again, what is a rational number? Is denoted by Q, is a set of all numbers of the form P divided by Q, where Q is not 0. P and Q are integers. When the rational number expressed as a decimal, it can be either terminating or keep repeating a decimal number. Converting a positive mixed number to an improper fraction. Multiply the denominator of the fraction in the fixed number by the integer preceding it. Add the product obtained in step 1 to the numerator of the fraction in a mixed number. The sum is the numerator of the improper fraction we are seeking. The denominator of the improper fraction we are seeking is the same. I'm sorry, should be, is the same. Oops. Same as the denominator of the fraction in a mixed number. Let's look at example 2 on page 252 of your textbook. Again, let's go to our tablet. Makes it easier to comprehend. Here, in our tablet here on page 252, example 2, converting from a mixed number to an improper fraction. So this is called a mixed number. When you have a fraction such as this, 3, and then we have 4 over 5. You see, now I'm going ahead of myself, but this part will be the decimal part when you write it this way. But now, for example, I'm just saying that you know ahead of time. But for now, just forget this part. Okay, we want to convert this mixed number to an improper fraction. What we do, you take this denominator, multiply it by the number here, so we have 3 times 5, okay, I'm sorry, let me do this again. So you multiply the denominator by the number right next to it. So you have 5 times 3 would be 15. You add this product to the numerator here. So we have our improper fraction would be 15 plus 4. The denominator remains the same. This becomes 19 over 5. This is called improper fraction. This is called a mixed number. All right. Now, if we want to write, if we want to do the other way around, if we have a mixed number, and we want to write, if we have an improper fraction and we want to write it as a mixed number, let's look at example number 3 at the bottom of that page. You have 42 over 5. You have this fraction. 42 divided by 5. This is called improper fraction because you see the numerator can be divided by the denominator. So in order to write it as a mixed number, you divide 42 by 5. Put 8. 8 times 5, 40. 2. Now, this is the remainder. This is the quotient. Okay, the way it's going to happen, the remainder goes to the numerator. This remainder goes here to the numerator. The quotient becomes the number right next to it. So the quotient here, 8, goes here. Oh, I'm sorry, this thing has become very messy. So the remainder goes to the numerator. Then the quotient becomes the number right here. Okay, and then the number that we were dividing by, 5, the denominator stays the same. So this is the mixed number. This is improper fraction. We converted that to a mixed number. This is the mixed improper fraction. We convert it to a mixed number. All right. Let's continue. Okay, we did that. Mixed number and improper fractions. Like a mixed number consists of a sum of an integer and a rational number expressed without the use of an addition sign. For example, 2 and 1/4. You know, we have 2 and 1/4. You take the 4 times 2, 8, plus 1, you get 9/4. Same thing. Yeah, we did that example. And we did the converting the positive improper fraction to a mixed number. We already did that. Converting improper fraction to a mixed number, 7 divided by 4. So 4 goes 1 time to 7. So the remainder becomes the numerator. The denominator remains the same, and then the quotient comes here. We did this example, 252 and 253. Okay. Multiplication by fraction, simple. Multiply the numerator, multiply the denominator, reduce the fraction if necessary. 2 times 5, 2/5 times 3/4. 2 times 3, 6, 4 times 5, 20. 6/20 can be simplified because 6 can be divided by 2 is 3, 20 divided by 2 is 10. Okay? Division. When you want to divide, basically, fractions, you have 4/5 divided by 2/3. You change the sign and reverse the other fraction. It's same as 4/5 times 3/2. And then multiply the numerator, denominator, 12/10. This, you can write it, simplify it if it's possible, if it's necessary. 12 divided by 10 goes to it 1 time, and and you know, actually 12 becomes this becomes 6/5, and 5 goes to 6 1 time, remainder 1, remainder goes here, the denominator same here, the quotient comes here. I hope you're following me. If not, let me show you. Let me get the new page. For example, okay, where was it? Let me get here. Okay, we had 4/5 divided by 2/3. Okay, let me. Okay. Okay. Remember, okay, we had, this was a number that we had. We had 4 divided by 4/5 divided by 2/3. Okay? So we said this is the same as you change this to multiplication and then reverse 2/3 to 3/2. So 4/5 times 3/2. 4 times 3, 12. 5 times 2, 10. This is what you get. Now, 12 divided by 10, 12/10, you can simplify this divided by 2 becomes 6. This divided by 2, this becomes 5. You can write this as a mixed number. 6 goes to 5 one time with a remainder of 1. So the remainder becomes the numerator. The denominator stays the same. The quotient 1 comes here. So that's what I meant in the PowerPoint. Okay. Adding fraction, again, before we can add or subtract fraction, they must have the common denominator. A common denominator is another name for a common multiple of the denominator. The lowest common denominator is the least common multiple of denominator. To add or subtract two fractions with a common denominator, we add or subtract their numerator and retain the common denominator. Writing fraction with a common denominator is accomplished with the fundamental laws of rational numbers. Look at here. We have 2 1/3 plus 3 3/4. Now 2 plus 3 is 5. Okay, that's clear. Now we have to deal with the fraction. We have 1/3 plus 3/4. You got to make their denominator the same. In order to do that and to find the least common denominator, multiply both of them by, for example, the denominator, like multiply this one by the denominator of this one and multiply that one by the denominator of this one. We take 1/3, multiply both the numerator and denominator by 4. 1/3 times 4 and 4 becomes 4/12. Then you take this one, multiply the top and bottom by 3, the denominator of the other one. 3/4 times 3/3 becomes 9/12. So now we have 4/12 plus 9/12. This is equal. When the denominator are the same, you just put the denominator, you have addition, you add 4 plus 9, 13. So you get 13/12. Or you can write that as a mixed number because 13 goes to 12 one time with a remainder of 1 and the denominator stays the same. 1/12. So we have 1/12 plus 5 from here. Now the 1 plus 5 is 6 and put a fraction right there. This is your answer. The irrational number, which is the famous one, is pi. An irrational number is a real number whose decimal representation is non-terminating and non-repeating decimal number. Keeps going. Every non-negative real number a has a unique non-negative square root called the principal square root, which is denoted by, here's the sign of a square root a, where a is the radical sign. They call it the radical. When we have irrational number like this, if the root are the same, we are getting the same root, we just put 1 and multiply them by together. Same with the division. 1 radical, the same root number, and then a over b. Again, product of root for radical for a greater than or equal to 0 and b greater than 0, the same over here. Okay. Square root. Simplifying a square root. Let's look at page 266. Example 1. And let me go to here, to our pad again, and get a thing. Okay. We wanted to go to page 266. And example 1. So let's do that. Okay. We have simplify, if possible, square root of, for example, 75. Okay. So we have square root of 75. This is equal 75. Here, prime factorization becomes helpful. Is a product of 25 times 3. 3 is a prime number. Now, this is equal to square root of 25 is 5 to power of 2 times 3. All right? So, 5 to power of 2. This, when there is no number here, it means it's 2. You divide, you take this, divided by this is 1. This comes out of the radical. This becomes 5. Power of 1 outside the radical. This one stays inside the radical. So this is your answer. Let's do number B, 500, square root of 500. Again, when there is no number, it means it's 2. 500 is 5 times 100. So 100 times 5. 100 is 10 to the power of 2 times 5. Again, this 2 gets divided by this 2, becomes 1, and 10 comes out of the radical. It will become 10 to square root of 5. This is your answer. Can't do anything with 5 because that's a prime number. All right. I guess that's, let's, for example, on page 267, we have square root of 2 multiplied by a square root of 5. What's the answer? The roots are the same, so we write 1 radical sign, 2 times 5, 10. All right? If we have, yeah, I guess the other ones are the same. Example number 3 on page 267. Let's look at that one. We have square root of 75. square root of 75 divided by square root of 3. Again, the roots are the same, so I can write this as one radical sign and divide 75 by 300. 75 by 3 is equal to 25. So we are getting a square root of 25. 25 is 5 to the power of 2. Now this 2 gets divided by this 2, and the 5 comes out. So you get 5. Actually, that's it. This is your answer, 5. All right. Let's go back to our PowerPoint. Okay. And actually asking, we did this one, 268 and 269. Again, let's do an example of each. Let's do 268. Let's do example 5 and example 6. Let's go back again. So then we need to go back to our pad. Well, let me get a new one. Okay. For example, example 4 on page 268, adding and subtracting square roots. Okay, we have 7 square root of 2 plus 5 square root of 5 square root of 2. Okay, this is equal to, when we have cases like this, you can you can factor it. This is same as 7 plus 5 times square root. What I did was I took this square root and this square root. I factored it out here, and I just add 7 plus 5 here. So this is equal to 12 square root of 2. Okay. Let's do number B. We have 2 square root of 5 and minus 6 square root of 5. Again, you factor this, we have a parenthesis, square root of 5, then 2 minus 6. 2 minus 6 is minus 4, square root of 5. Same thing, it keeps going on. Let's look at example 6 on page 269. Let me get a new sheet. Let's see what's going on. Yeah. Okay. Let's go to page 266. I'm sorry, 269, example 6. We want to rationalize the denominator. We have 15 over a square root of 16. All right. in order to do that, I multiply both side, both top and bottom by a square root of 6. So this becomes 15 times square root of 6. Square root of 6 times square root of 6 is equal to 6, because 6 times 6 is 6 to the power of 2. This is same as square root of 6 times 6, or 6 to the power of 2, which is 6. This comes here, and that's in the top. So we have 15 square root of 6 over 6. Now, this can be simplified. 15 can be divided by 3, becomes 5. 6 divided by 3 becomes 2. So we can 5 square root of 6 and times 3 times 2, so over 3, I'm sorry, not 3 times 2, over 3. This is your answer. All right. Oh, I'm sorry, this divided this by 3 becomes 5, divided by 3 becomes 2. I'm sorry, this not 3, but 2. Okay. All right. Let's go back to our PowerPoint. We did this. Real number and their properties. See, the real numbers consist of irrational and rational number. Rational number, these are all rational, consist integers, whole, natural numbers. Irrational pi, square root of 3, 5. It means it keeps going. It doesn't stop. It's not a terminating decimal, and it's not a repeating decimal. Some of the very important properties. I'm sorry. If an operation is performed on any two elements of a set and result is an element of the set, we say that the set is closed under the given operation. Three important properties: commutative, associative, and distributive property. A plus B is equal to B plus A. A times B is the same as B times A when A and B are real number. Associative property. A plus B and then add C is the same as A plus first B plus C and then add A. A times B and then times C is the same as B times C and then times A. Distributive property. If I have B plus C and A over here, multiplication, it can be distributed. It's A times B and A times C for A and B be real numbers. Exponents and scientific notation. When we write a number like this, this is called writing in an exponent format. 5 to the power of 2. 2 is referred as an exponent. 5 is the base. Read 5 to the power of 2. 5 to the second power, or 5 squared. Let me see, what do we have on page 282 and 283. Okay, on table 5.4, just review that the product rule. If you have two numbers with different exponent, multiply, you can write one number and add the exponent. 9 to the power of 6 times 9 to the power of 12 is same as 9 to the power of 6 plus 12, or 18. If you have, these are very important. Now, let me show it to you on my pad. if you have, let's say, so you have 9 to power of 6 multiplied by 9 to power of 12. The base are the same, so you write 9 to power of, you just add these two. 6 plus 12 is 18. If you have a number b to power of m, and then parentheses n, this is the same as b to power of mn. For example, if I have a parenthesis 3 to power of 4, then I have 5 here. This is same as 3 to power of 4 times 5, or 3 to power of 20. If I have b divided by b, this one m, this one n exponent, this is same as keep the base m minus n. If I have 15 to power of 12 and 15 to power of 4, this is the same as 15 to power of 12 minus 4, or 15 to power of 8. All right? Okay. Zero exponent is any number to power of 0 is equal to 1. Any number to power of negative is same as 1 divided by that number to power of positive. Okay. Product rule of exponent, I talked about that. A times A, you just add rule of exponent. We talked about that, and we talked about that already. Scientific notation, a positive number is written in scientific notation versus exponential notation. Then we write a to power of 10 to power of n. A times 10 to power of n. A is a number greater than or equal to 1 and less than 10. And n is an integer. This kind of writing is called scientific notation. To change a number in scientific notation to decimal notation, observe the exponent on the 10th. If the exponent is positive, move the decimal point in the number to the right, the same number of places as the exponent. Adding zeros to the number might be necessary. If the exponent is negative, move the decimal point to in the number to the left. The same number of places as the exponent, adding 0 might be necessary. Let's look at example 285, page 285, example 3. All right. Let me also go to my and get a new one. Here, example 3 on page 285. We have 2.6 times 10 to power of 7. This is called scientific notation. You have a number times base 10 and 7, and then this must be an integer. We want to write that down in a decimal format. Now, we said, think of 20, just take this, 26. This is positive. It's 7 positive. So you move the decimal point 7 places to the right. Okay? So this decimal point was here. So I move 7 places to the right. 1, then we did 1, then I move 2, 3, 4, 5, 6, 7. So, see, the decimal point was here, okay? This is positive. So I moved the decimal point 7 times this way. I moved it from here, moved 1, 2, 3, 4, 5, 6, 7. Actually, you don't need to write it. Now, this is writing in a decimal format. If it's negative, 1.1 times 10 to the power of minus 4. Okay, this is the same as. This is scientific notation. Take here, 1, the decimal point is here. This is negative, so we move this way to the left. I move 1, 2, 3, 4, and I put the decimal here and a 0 here. Okay, so I move this one, the decimal point here, 4 times to the left. 1, 2, 3. Actually, no, wait a minute. I moved, yeah. I'm sorry. 1, 2, 3, and 4. I missed this part. Okay? I hope, let me do this again. I don't want you to be confused. Okay. So, let me, okay, no, it doesn't matter. Okay. You see, I moved this 4 points, 4 units to the left. Okay, it was right here, all right? So I moved it 1, 2, 3, 4. Put it here. I hope this is clear. All right. Converting from decimal notation to scientific notation, move the decimal point in the original number to the right or to the left until you obtain the number greater than or equal to 0 and less than 10. Count the number of places where you have moved the decimal point to obtain the number in step 1. If the decimal point was moved over to the left, the count is to be considered positive. If the decimal point was moved, actually, should be was moved, sorry, to the right, the count is to be considered negative. Multiply the number obtained in step 1 by 10 raised to the count found in step 2. Let's look at an example to make it clear. Let's go to page 286 and example number 4. And maybe it's again, let me go to our pad. Okay, here we want to convert a decimal notation to a scientific notation. For example, number A, we have 4,600,000, okay? We want to write that in a decimal, in a scientific notation. Remember, the scientific notation, we had 10 to some kind of integer. In order to find what kind of integer we need to use, I want to put this, I need these 2 digits, 4 and 0.6, and what number of integer I need, that depends on how many units I'm moving the decimal point. The decimal point is actually here. So I'm moving it 1, 2, 3, 4, 5, and 6. So this should be 10 to the power of 6. This is how you convert a decimal to scientific notation. excuse me. Let's look at another one. Here we have 0.000023. This is the same as, again, take this 23, put the decimal here, times 10 to power of, now you're moving this way. It was, the decimal point is here. I moved it 1, 2, 3, 4, 5, that direction. So this has to be in a negative direction. This is negative. So this should be 10 to power of minus 5. All right. All right. Let me see. Oops. Computation with scientific notation, example 6, page 287. You know, when you have multiplication of numbers in scientific notation, like you have those two parentheses, in order to do that, you regroup factors. 3.4 times 10 to the power of 9, 2 times 10 to the power of minus 2. So write the first parenthesis, 3.4 times 2, then 10 to the power of 9 times 10 to the power of minus 5. Remember the rules, 9 minus 5 is minus 4. Let me, maybe I show it on the graph, it would be easier. Okay, we have example number 6 on page 287. We have here 3.4 times 10 to the power of 9. Okay, oops. Times 2 times 10 to the power of minus 5. All right, so we do regrouping. Take 3.4 and 2. And remember, I put them in a new parenthesis, 3.4 times 2. The second parenthesis, I deal with these, 10 to the power of 9 and 10 to the power of minus 5. 10 to the power of 9 times 10 to the power of minus 5. Remember, the rule here was when you have that kind of operation, this is same as 10 to the power of 9 plus minus 5, which is same as 10 to the power of 9 minus 5, same as 10 to the power of 4. So we have 3.4 times 2 times 10 to the power of 4. 3.4 times 2 is 6.8 times 10 to the power of 4. So this is your answer. This whole thing. Or you can write it in a decimal format, 6.8 times 10 to the power of 4. You know, you because this is positive, so you move this direction. So you get 68, and you move the decimal. You moved it 1, 2, 3, 4. So I need 0, 0, and 0. All right? Okay. Arithmetic and geometric sequence, a sequence in which each term after the first term differs from the preceding term by a constant amount is called arithmetic sequence. The amount by which each pair of the successive term differs is called common difference. Oops. If you look at page 294, for example, example number 1, if you add 4 to 6, you get 10. Add 4 to 10, you get 14. Keep going, you get 18, 22, 26. So this is arithmetic sequence, and the common difference is 4. If you have a sequence 5, 3, 1, -1, -3, -5, then it tells you the difference between 5 and 3 is 2, between 3 and 1 is 2, between 1 and -1 is 2. So you're going down by 2. So the difference, the common difference is -2. All right. Okay. And I think that's it. Let's see if anything else needs to be done. Let's do example 8 on page 288. And with this, we finished. Okay. Example 8, page 288. We want to multiply using scientific notation to multiply. So we have 0.0064 times 9,400,000. This is actually 9,400,000,000, and we are multiplying that by 0 point decimal is right here. Okay, so if I want to use scientific notation, these are in decimal notation. The decimal point for this one is right here. This one, I take 64 times 10 to the power of. Remember, I'm moving the decimal point that way. The decimal point is here. I want to move it this way, so it becomes negative. I am moving it 1, 2, 3, 4. So 64 to the power of -4. All right? Times this number. Now I want to move this decimal here. I want to move it to this point. So I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? So this is what you have. Again, do the factoring. 64 times 9.4, 10 to the power of -4, times 10 to the power of 9. Now, let's work with this. This is the same as this is the same as 10 to the power of -4 plus 9 would be +5. Okay? 64 times 9.4 would be will end up to be here. This is when we multiply those is 60 times 60.16. So we have 60.16 times 10 to the power of 5, which this is equal to, if I want to make it a scientific notation, I want to move this point here over here. So I want to have 6.016 times 10 to the power of, if I'm moving this 1 over there, I have to add 1 to the exponent here. This should be 10 to the power of 6. Okay? All right, I hope this is clear, and I hope you're doing well in all your studies. This would be the end of our session. May the Lord bless you and keep you. If you have any question, please feel free to contact me. If you have any question, please feel free to contact me. I'm here to help you. Again, don't be afraid. Just study your textbook. Nothing can replace your textbook. Study the textbook, watch this video, go over the PowerPoint, but make sure that you study your textbook. God bless you all. Take care.